Find the volume of the solid obtained by rotating the region bounded by y equals 18 over x plus 1 times x squared plus 9, y equals 0, x equals root 3, and x equals 3. This will be rotated about the line x equals -1. Let's draw the graph. Now this function isn't one that we graph on an everyday basis, but we can get an idea of what it looks like. That's all we need is a sketch. Ultimately, there's a polynomial in the denominator, and its power is a cube. I mean, the 18 will affect the graph, yes, but basically this graph is going to kind of look like 1 over x cubed looks. So when x is 0, let's figure out what y is. Plug a 0 into our function, not to 1 over x cubed, but to this guy here. 1 over x cubed kind of looks like 1 over x, where we have following situation. We have the y-axis, the x-axis. It kind of looks like that. 1 over x cubed does. It also does this, though. Now, when x is 0 for us, we'd have a 1 and a 9. 18 divided by 9, we get that y is 2. And then as x gets large, then the denominator is going to get large while the numerator is staying at 18. So y is going to get small. Pretty much that's all we need. Okay, when x is 0, we have we hit it 2, and then we decrease down, asymptotically approach y equals 0. Then we have these guys who are just vertical lines. X equals root 3 and x equals 3. Just vertical lines. X equals root 3 is smaller. So you have just draw the vertical lines, and then y equals 0. That's just the x-axis. So here's our region. Great. Rotate it about the line x equals -1. Okay, let's figure out which method we're going to use. Step 2. Have two graphs. And on one, draw a rectangle parallel to the axis of rotation. On the other, draw a rectangle that is perpendicular to the axis of rotation. We're going to have an issue here because as this rectangle moves, the right end of it changes. That's going to be an issue. For the one that's parallel, that's going to be shell in x because it's vertical. It's going to be moved from left to right. For the one that is perpendicular, it's kind of part washer. I mean, I guess it's all washer. Not disk and washer, sorry. No, it's all washer. And it's going to be in y, but we can't do it anyway. Why can't we do it? Because it's in y, we need the formula solved x as a function of y. Can't be done. So, definitely not that. So we have shell. Great. In x. Formula for shell. Going to need the radius and the height. How do you get the radius? You attach the axis of rotation to the rectangle. So what we have is the sum of two distances. We have this purple distance, which is the distance off of the y-axis, and this green distance, which is the distance back to the axis of rotation. Distance off the y-axis is x, and since the variable that we're integrating in is x, then we can just add to that x. The purple plus the green is the orange, so x. Now how long is the green? Well, the green is constantly going to be 1 no matter where the rectangle is at. I just put it up here so we can see them different like that. No, it's the same. So x plus 1 would be the x for the purple, 1 for the green. X plus 1 would be the radius. Now we have the height. That's just how tall the rectangle is. And it's just up to the function. Limits of integration. The left hand was root 3. The right hand was 3. So we have the radius multiplied by the height. These guys cancel each other out. These x plus 1s. The 18 can come outside with the 2 to make 36 pi. And we need to be able to integrate 1 over x squared plus 9 from root 3 to 3. And that would be our volume. Okay, let's execute that on the next slide. We're going to perform that calculation. How do you find the antiderivative of 1 over x squared plus 9? It would be great if the 9 was a 1, because the antiderivative of 1 over x squared plus 1 is the arctan of x. This guy here is arctan's derivative. But we don't have a 1, we have a 9. So we need to do some algebra. Let's algebraically manipulate it so the 9 turns into a 1. How can you make a 9 turn into a 1? You have to factor out. So factor out a 9 from the denominator. And so the x squared will become x squared over 9. And the 9 becomes the 1 that we want. Pull the 9 all the way out. It's in the denominator though, so 36 divided by the 9 is a 4. Conveniently rewrite x squared over 9 to be the quantity of x over 3 squared. It's looking more and more like what we desire. We just need the x over 3 replaced by some variable. Classic U substitution situation. If u replaces that x over 3, then we have exactly 1 over u squared plus 1. Take the derivative to figure out how you can replace dx. So the derivative of this is 1/3 of dx. You have to replace dx, substitute for it. So you multiply both sides by 3, and you get the 3 times du will replace dx. So we know how dx gets replaced, and now we know how the integrand gets replaced. Simply, we have the 4 pi that was outside. Don't worry about the limits. The 3 du replacing the dx, and then x over 3 replaced by u. We have 1 over u squared plus 1. All right, great. That's an integral that we can do. U substitution switches this into a doable integral. Pull the 3 out. We simply have 12 pi times this integral. We already know that the antiderivative would be the arctan of u. So I consider, u substitution sort of scratch work. We need to see it in order to figure out what this antiderivative was. Intuition didn't get it for us, so we needed this tool, u substitution, and now we can replace the u with x over 3, and we have 12 pi, the arctan of x over 3. We need to plug a 3 in. We need to plug a root 3 in. So we have the arctan of 1, because it's 3 over 3. And then the arctan of root 3 over 3. All right, great. Root 3 over 3. Well, first let's deal with the arctan of 1. This is a question asked and reversed. It's what angle gives you a tangent of 1? That's how you do arctan. You ask that question, you answer that question. And the one angle that has sine and cosine the same is pi over 4. So this guy here is pi over 4. What about the other guy here? Root 3 over 3. Now for that one, you have to, I guess, either have a unit circle on you to answer that question backwards. It helps to know that root 3 over 3 is 1 over root 3. And this is one of our 45, 60, 30 multiples. And so if we interject top and bottom being multiplied by a half, the numerator is a half, and the denominator is root 3 over 2. So this is someone's tangent, where the sine is a half, and the cosine is root 3 over 2. One angle has a sine of a half and a cosine of root 3 over 2. It's going to be pi over 6. Okay. But have yourself a unit circle that has tangent marked off so that you can get that quickly. And we're almost done. Common denominator of 12. So we times by 3. We times by 2. 3 pi minus 2 pi is just pi over 12. But it's times 12 pi. The 12s cancel. And the final answer is pi squared.